Welcome to my lesson on engineering methods and the practical application in kitchen planning and design. I will show you how to use these methods to enjoy your kitchen in use. When you plan a kitchen, it is better to start easy. Print a space plan or pick up some paper and draw your idea by hand from the top view. And add all necessary dimensions to the drawing to check for obvious curiosities. And you will end up to something similar to what I show you on the left side. You probably have an island, you have some additional working area and some cupboards, and the dimensions I mentioned. These two are just for an example. You might have several more needed. And as I have designed my kitchen already in a tool, we can take a look for better understanding. You see the island in the center. It is the same as here on the left top side. And along the wall, we have some workspace and, as I mentioned, the cupboards with a lot of storage room and an additional storage space behind the store. If you plan to use your kitchen daily, one of the most important aspects is a fast and easy usability to get the things done. But how to optimize or even measure it? Usability can be checked by specific scenarios. In our case, in the kitchen, like cooking, doing the dishes, or for example, putting away the groceries which you just got from the mall. Let's design our personal scenario. For our example right now, I choose putting away groceries. And the first things we do, we define the stations which we need in our kitchen. Simply some random numbers in my case. And as next, we connect them in a logical order. Which stations are we visiting when? They are indicated here from A to G. And to don't get confused, we need to define what these definitions are. We go through them. The first station, number 4, it is the area where the bags are stored, which we need for shopping. And the connection between the stations is an action. What are we doing between the stations? For example, we grab the bags and move to the exit or entrance if we come back. And what we are doing it in between is we go shopping. It's indicated by this circuit arrow, which is coming back to the 0. We enter the kitchen again, putting down the bags on a working space, which is indicated by number 1. We unload our bags in a similar area right next to it. And we put away our groceries to 3 different destinations. To the fridge, it is 31. To the cabinet, 32. And the storage room, indicated here by 33. And at the end, we put away the bags back to the number 4. Get sure that your scenarios are starting and ending in the same station. Otherwise, you are not complete. You have missed something. And by defining this example, my first design of the scenario, I missed station 4, for example. That's why it's the last, but in reality, it's the first step which we are doing. To complete the scenario definition, we need to specify the distances of our connections by measurement or calculating. Just write the numbers to it. And we have also to define an average shopping tour which we are doing. In my case, I decided I'm shopping 20 parts. 10 of them have to be stored in the fridge. 8 of them have to be stored in the cupboard, and 2 have to be stored in the storage room. In addition to that, we need to know if we are walking this distances backwards and forwards, which are indicated by the arrows, and also wrote down in a table in Excel. Then it's easy to calculate it directly. So for example, for F, we have to run from 2 to 33 forward and backward. That's why we have a number 2 here. And to store 2 parts at 33, we run it 1 time. Other destinations we run, for example, 10 times. And if we have that available, we can calculate the distances which we run and add them together to a number of 35 meters, which we typically need for an average shopping tour. Sorry, I mean to store groceries after shopping. With this number of 35 meters, we can easily compare different configurations of your kitchen design with high quality. Let me give you some hints and motivation for executing such an exercise on your own project. I had in design, an initial one, where my fridge was at the bottom of the kitchen. This is a 31. And the same scenario resulted in 40-meter distance for an average grocery storing activity. When I redesigned it, it results in 35 meters. Such an iteration is very typical, even in engineering approaches. We design, we check. We adapt, we check again. And take a look if we can decrease these numbers. The main effort of this approach is in the definition of your personal scenarios. Once they've been done, you simply move the stations around and you can correct these numbers in Excel, and it's directly showing you the results, and you see if you can decrease these numbers. So don't get afraid of the complete process. The initial one to set up the scenarios is the main work. And get sure that you design the most frequent scenarios too, like cooking or making the dishes, which are done several times daily, and maybe have a higher priority for you as storing groceries. Think also about if usability or being fast in the kitchen is the highest priority for you. It might be not even the case. And now you have an easy strategy and method available to optimize your designs yourself. Unfortunately, there is no one who can do this work for you, as scenarios are very personal. I hope you enjoyed this video and got some motivation to use this approach or show it to others. Goodbye.